So how's it going, everyone? Welcome. Blair Gonzalez here, and today let's go to now explore about the asynchronous updates, which is part of the fact that now anytime that you update an state, you must be well aware of this. Why? Because if you are going to be a web UI, I am a web UI developer. It is important to understand now these three components that makes the web development. HTML, CSS, and JavaScript. So in order to do that, so there's a couple series of videos, me taking notes of the JavaScript based from the You Don't Know series, and how important it is for us to understand that this is the way how we can now add behavior or modify it. Okay, so now our document, which is the structure, the HTML, can now behave the way we want. And when it comes to provide now particular style, using CSS. So Joshua Kerman will actually make these two courses when he first look at the CSS for JavaScript developers, and now is React, right? Uh, so here in the joy of React, because at the end of the day, we wanted to understand how do we get here. By first, I'm gonna make a quick recap of this. I don't want to dive deep too much in all of this topic. But it turns out that in the model one, we look at what React is. What is the goal of React? Who made this? What is the problem that they're trying to solve? Which is how you can now have one particular state and then share that across different UI. And not only that, keep that sync across different UI. So by having now this particular state here defined as a component, we can now use React is in different environments. So whether it's on the browser with the React DOM, or with the React Native to target specific UI elements across Windows, mobile, React, iOS, and Android, and also is the WebLG, right? So you can know how to, for example, working with directive like light, camera, and other stuff. So I do find that that's quite interesting. So React is the developer surface that allow us is to interact with these different environments, right? So we also look at what is React in itself, which is a plain single object that describe is the UI or that HTML element at that moment. Okay, and they have the type, they have the ref, they have the key, and they have the props, and inside of the props it has all the property that this tag has, which we can now dynamically is modify its behavior and values, as well as the children, right? Which is the nested content that this component has. So because this can be lengthy and verbose anytime that you want to create now a React element, we look at the shorthand syntax known as GSX. So GSX at the end of the day is this markup language that combines JavaScript with HTML. We look at the anatomy of that, how you can define as a GSX expression, and the difference with the HTML, which is the reserved keywords that we have. So for example, HTML4s or class name, as well as the case sensitive attributes and tags, and also is the the self-closing tag, okay, for content that are not uh, for 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 content that you're not going to pass, like anything that is in the in ankle bracket. And what is GSX? All right, and how GSX works by transpiling that content from this markup language into a JavaScript, which is eventually is this React create elements. So because we or I look at another difference of the GSS, which is how do you compare that with template string or template engines, okay? And what are the features that React now exposed to us, such as React fragment, as a way to avoid polluting the DOM, okay? So this is helpful, especially if you want to render is a chunk or a collections of elements, right? Uh, Without having to wrap them into a div, for example, a div that doesn't that only act as an anchor, just like that. So that's great, and also is looking at how we can now organize a particularly applications using now the entry point as the index where you pass, for example, is the configurations or configurations like the style sheets. Also the app.js, which is the home app, all right, where you define here things like state that you want to make access through the entire application in React, okay, and also is the models where you define is this custom elements as components. So all of this is just to now understand at this particular way of building applications, which is in this component way, right? This component architecture. So when you have now the HTML and CSS in JavaScript all in the same file, all right, and because of this, it has a particular anatomy. So we look at how can we define is our component, what is the component syntax, how does it look like, what are the properties that this can have access, such as props and children's, and what children's means, which is the content that we receive in order to pass down and to recreate all of the other elements that that component might have. And this is not a particularly, this is an HTML attribute that exists here. So this HTML or this properties that are injected at runtime, and we also look what happens there, okay? So the props and the props and the children, they are now injected at runtime, okay. We also look at how can we now iterate through a collections of elements or map over them using now is existing JavaScript methods to do so. So for example, like mapping, and when you are mapping and telling now React via the syntax expression to GSX, to telling, hey, I want you to now is create each one of those elements once you parse that into a JavaScript. So because React doesn't have any way for that to uniquely identify those elements, that's what we need to put now is the key and use now a particular specific index for that. So why we cannot use the index of the array? Because this is something that can change. It might vary. And yeah, because this is something that can change. It will vary, and if it does, then now your elements might have is in a wonky state. So again, that's go beyond the scope of today's video, but I just want to bring that out and how to do that. And when it comes to now uh, conditionally rendering elements, we have different strategies, such as the if statement or expression or using is CSS. So for if a statement is pretty straightforward, right? It's using that if and check that inside of the function, aka your component. The other is that using is the ampersand, which act like an if statement, all right? And how now the this I works behind the scenes. It works like a gate, all right? Like the bouncer in the database, or like the bouncer uh, that tells you, hey, you should pass or not this n. Uh, and also is the conditional or the ternary operator that act like an if else, and the exactly, and the how do you put it? All right, and the and then the way how you can now render elements via CSS. Okay, so conditionally rendering via CSS, and how now we use a specific component because the area label doesn't work quite well across different browsers. So this particular snippet that wrap this element content that you pass or that you can define uh, to now don't show this content to normal users, but do that for assistant technologies. I do find that that's quite interesting. Absolutely, absolutely. So, okay. So, um, because this is just to describe is the conditionally rendering, okay? And also another topic that is important as part of the introduction, which is the style and how you can now provide style. And because style is something that you can define as an object and is quite tedious in verbose, we back in the old days we have different methodologies like Ben, block element model, but that require is discipline for the developers to go with, and not only that for others developers as well. And based on my experience, we as I and I assume that as individuals, we are not, so we don't follow is we are not disciplined. Not even if we have uh, if that if that realization of knowing why we have to do the kind of thing that we need to do, if that doesn't come, if that is not intrinsic, it won't stick. Therefore, the discipline won't emerge. The performance won't emerge. The industry now has shown that. And one of the reasons why the ban, despite all of his efforts, hasn't been applied as a methodology of this. So not only that, because it's also make you think very well about the name that you want to use. So AKA is stick you in this particularly namespace. So you can now have his name collision with that. So in any case, because of that, and we need to have now in our React development is CSS that are scoped to that. Well, a lot of the time, this is something that has quite time here on the ground, is well, this CSS model is a way of how can we now is select all of or based on a CSS get all of these selectors, uh, generate a long enough custom long and specific name for that in CSS, and then now allows to access those selectors like if they were and allows to access all of these selectors as as property objects here. That's quite interesting, and the way of how it does, who made that, is this model bundlers, which is part of the tool of the tray, right? Like Webpack or Vite or any other model bundler out there. Okay. So this is just the principles, right? So here in now working with states, my first understanding is how can we now add interactivity to the user? How traditionally we add how we respond to user events, okay? How React does that? How can we now define is our states using use state, understand what happened when we update that state, which is the core loop, all right? And also looking at how can we work with forms, one of the most favorite topics. uh, and how can we work is now with complex states and some gotchas to avoid, which is part of the discussion. So this event handlers described briefly is how now do we handle errors here, okay? Or traditionally, so by query selector, by using query selector or document get element by ID, so we get that element, right? And then now attach a functions to the event listener. This is one way of how you can now add behaviors to these elements. And the other is, well, in that particular HTML, if that exists, let's go into now is use an existing event. For example, the onClick, all right? So now pass is the execution of the function. So when the function was called, you're gonna pass now is the function execution. But this is not the case in React, because if you want to now pass a behavior to a particular element, you pass now is a reference as a function to that event handler, and the difference here is how you can now is pass. So how you can now pass arguments, and the difference between the HTML way and the React way. That is passing is passing is the arguments here, okay. Using is an inline function, and as we look previously, so the name of the events are now in this camel case. So when we now want to add functionality, dynamic functionality to our components, all right, such as adding a counter, and now the button can reply it. We use now particularly hook, which allow us to keep track states. So this state is using now this particular hook called use state. We look at how can we define that, the name conventions that it give us, all right, which is part of the React ecosystem. So it give us now the this tuple, the value and the setter function, right? And this is something that we can use in our React component to now is provide interactivity. So in order to understand now how this things works, if we convert that particularly, let's say, counter elements from GSX into a React elements, we have now all of this as React create elements as it is. And when we run that function, will give us now is the JSON that describes the UI at that particular moment. So initially, React, when your application is mounted, is going to recreate all of these elements from scratch and append all of this to the DOM. So it's going to recreate the entire UI elements. So for example, in this application, this is exactly what it is. So when the application is mounted initially, so when you call via the URL here, so it's going to now load so it's going to load the initial document. It's also going to fetch is the CSS and the JavaScript. So once that is parsed, now is going to execute the React code, which describe is what it's going to do initially, which is appending all of these elements using the document dot append element, right? Which is the React create element. It's going to append all of these elements to the DOM, and then going to create that. And then after that is done, the layout, which is calculated by the CSS spec and implemented in the browser, is going to determine is the geometry and the layout or the position of all of these elements, right? So once that is computed, if there is some additional layers that needs to be computed, so for example, on the graphical extension or on the graphical processing unit, GPU, well, we have now a particularly phase called is the composite. And then after that, it's going to render, it's going to paint all of these pixels on the screen. So it knows all the information needed to paint all of the pixels on the screen. So that was a huge overview of what happens when we mount the component. So when the component is updated, or when the state is updated via the setter function, so what happened here is that now that triggers a notification in React that tell, hey, these components update its state. React identified that components and then now renders that or re-renders that. So which means is it's going to now transform that element or execute that JavaScript function, right? And if it contains more React elements or more components there, it's going to continue to call all of the components until there is no more to do that, which create, when you run that function, it creates now a visual it create a object which contain is this new snapshot of how the UI should look like. So now when the React compare is the previous snapshot with the new snapshot by playing the game of spot the difference via the diffing algorithm, which is an optimized fancy algorithms to spot the difference, right? Now with that information, so now React is going to in a very surgical way update only those elements in the DOM that that have changed across snapshots, right? which is known as the commit phase. So once React does that, so then the browser detects the DOM updates, and therefore is going to now is uh, repaints that. However, we need to understand what is the difference between is the render and the painting, because rendering in most programming, in most graphical computer programming, is like take our own processed raw input and generate some ready to use output, right? So for example, if you take now a particularly Blender image, and then you render that, it's gonna give you now is applying all of the materials and lightnings, and so forth, so on and so forth. It's gonna give you now this final output ready to be used. But in the case of React, renders mean something slightly different. This is also cause of the confusion. I was include that. So render here, it means that React is going to now uh, calculate is the difference between a snapshots. That's what the rendering is here. Mm-hmm. That's what the rendering is. So when React re-renders, okay, it's a process of how to figuring out what needs to be changed. Okay, part of the reconciliation algorithm, right? So if something changed between the snapshots, well, it's going to now commit those change by editing the DOM to match the latest snapshot. So whenever the DOM, whenever a DOM is edited, the browser will repaint that, aka will redraw that, the relevant pixels to the user to show the correct UI. And all re-renders and all of this spotting the difference, all of this, yeah, all of this spotting difference. So not all re-renders, not all difference between different snapshots requires repaint. As we look in a particular example for that, right? As we look in this particular example for that. And this is critical. The critical thing to understand is that when we talk about re-rendering, we are not saying that we must throw the current UI to rebuild everything from scratch. React tried to keep the repainting at minimum because repainting is slow. Instead of generating a bunch of new DOM nodes from scratch, a lot of painting, it's figuring out what changed been what changed between snapshot and makes it require tweak with surgical precision. So this is to understand is the difference between the rendering and the painting, right? So far so good. We know Okay. So not all re-renders require repaintings. So this is just to describe is this particularly the core loop of using a user state and be able to describe in the most succinct way possible. So another thing is that all of these updates are asynchronous. And if you think about a little bit that if you have, for example, a component that has several of these states, and if you, for some reason, make all of these state updates synchronous, so you will need to, if you work in the React team, you will need to update is the which is I really love about the particular example here. So you will need is to update is the state. Okay, so you will need to update is that particular state. For example, here in this sandbox. So for example, if you have several of these states, all right. So anytime that you now perform an state updates inside of an event handler, and you pass that as a reference. So for example, like this, you will have to update is this, aka call this component and compute all of these values and show that the user at this moment is null. So you have to now show this and then now go to the next line and update that. So and then now go to the next line and compute this function again when now the user is set to null. Now the status is set to initial. All right, so if the user is now so if you have a particular user, all right, or if you don't have any user here, exactly, if you don't have any user, now the initial will be is the status will be initial, but we have not show something in the confirmation message. And the same will go through if we do this again. Set the confirmation message is going to now have to calculate the app again with now with the user as null, the set status as initial, and the confirmation message with this value, and then it's going to now show you that. But as you can see with this silly example, this is the reason why now a state updates in React makes sense that they are now asynchronously. Okay. So I also look at a couple exercise here, bastions and basilicks. Okay. When it comes to now shows that, right? And how we can now is compute is the new state of that. So by defining, this is also true, for example, if we're using other stuff out there, for example, Immutable.js, so on and so forth, but it makes a lot of sense on all of this. Okay, so here you're computing is the new state, all right? You pass that new state to the updater function, and therefore if you want to now somehow shows that, okay, now you show is this new computed state, which is exactly what we did here in order to show now that with the correct with the correct data. So in the next time it has now 8, in the next time it has now 9, and so on and so forth, right? So okay, and the other is a counter here. Might be a little bit more verbose, but for any of these interactions, the user interaction here, one way to do that is defining is each specific behavior for each specific button, all right? And then inside of that is update the proper state as it is, right? Which is exactly what we did here. We just want to update this and so on and so forth. And if we want to generate now random numbers by using is this yeah, by using is this how do we call it? Yeah, so by using is now um, all right. So by using now is the crypto get random values here and pass now is an array. This is interesting. An unsigned 8-bit array. And I do find that this was very, very beautiful to describe here, just as a fancy way to say it, right? Uh, to say, hey, the values that I want to show here, the random values that I want to show here, are in the range of 8 bits, all right? So it goes from 0 to 255. That's the bigger random number that we can have here. But in this case, I limit that. So let me actually show you this, right? Let me actually show you this. So here we're saying is by defining is this new array here. So the possible values that we can have here, all right? It goes yes. This is the buffer. Holy moly, memory inspector. You gotta be fucking. God damn, that's wild. Not applicable. Decimal, octal, decimal. Holy fuck. That's beautiful, man. So we can also what's new? Holy fuck. Okay. That's quite interesting. That's pretty fucked up. Okay. Interesting. So here, this unsigned integer A array. Holy moly, bro. Holy moly. 0, 0 and point. Little Indian, big Indian. Mm-hmm. So by defining is this on a right end, okay? That I know that might be go beyond the scope of today's video. Okay, you are now defining is the size of this, whether it is a type, whether it is a size, a type array, object, or buffer. Mm-hmm. Hey, this will be now my fixed space here. Mm-hmm. So how many? Okay, so how many slot of 8 bits or 16 or 32, 64, 128, 256, so on and so forth, do I want? Mm-hmm. Okay. From an iterable here. That's also powerful, bro. That's also powerful, bro. Mm-hmm. 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 Or you can define is a type array here. Mm-hmm. So here I'm saying is that hey, I want you to create now is 2 slot or 3 slots, right? 3 slot of this. Okay, so now I have is this 3 slot of here. So if I want to define is the value of each one of those slots, okay, I can now have access individually and say, hey, the value of the first slot, okay, will be now 255, right? And they say, hey, 255. And when I take a look now at the array, it actually here. But because this is an on-site 8-bit, okay, I cannot assign any value that are greater than that. I define it as exactly. I cannot assign any value that are greater than that, because otherwise it's going to now say, hey, it's now 1. You know, because that's the greatest values that I can store in there. So essentially, what we're doing here, okay, is to say, hey, reserve a space in memory of 8 bits, all right, unsigned for me, and then I want to now pass this. I want to now pass is this array to generate is a collection of random numbers, which in other words is this collection is based on the array that I'm passing. Since here I'm passing is just only 1 slot, okay, that makes a lot of sense. That makes a lot of sense. So for example here, so and then if I do this, right, and then assign that to random numbers, okay, let's gonna do this with the let, all right, and then now console log is the random numbers, okay, so now it actually is generate random number is but in this range here. So for example, if I say that, hey, random number, I want you to return is random number, for example, right? And then if I do this, the maximum value possible number, it is now 255 based on this, okay? But if I now, in my case, say, hey, let's go to now define is the maximum possible value that this can be generated using the mod here, using the mod here between the max and the min, using the mod of this, right? So now I'm saying is that, hey, the reminder is whatever I want to divide this. That's the greatest number that I can define here. That was quite interesting. Absolutely, absolutely. In order to understand and recap this stuff here. And okay. So then we look at now why the dance. Okay.
So this is a meme that was circulating around JavaScript Twitter a few weeks ago. It features TikTok sensation Kabi Lame, and if you're not familiar with his videos, I highly recommend them. But the joke here is that you have all this fuss, right? All this ridiculous over-engineering to manage a state variable in React, And when you compare that to something like Svelte, that's what this little S logo is down here, where in Svelte you just have variables, and it feels so much more intuitive and obvious. And it does sort of beg the question, like, why do we need all this stuff? Like, why can't we have something simpler? So, in this video I want to talk through why React does things the way that it does, why it can't do it the way Svelte does it, and why that might not necessarily be a bad thing. And I think the best way to start is, let's look at our counterexample again, and I'm going to try to convert this to do things the Svelte way, and we'll see if it's even possible and what the limitations are and why it doesn't work. So I'm going to replace all of this fun stuff with let count equals 0, like from the meme. And when I click on the button, I'm going to say count is equal to count plus 1. And
right.
As you probably expected, it doesn't work, right? But why doesn't it work, right? Why can't we do it this way? Well, the first thing we run into is that JavaScript doesn't really give us a way to observe variables. We would need to know when this variable changes in order for React to trigger a re-render. The only way that this UI updates, the way for us to see the number here, is for all of this code to rerun. And it doesn't automatically rerun that code when you change a variable.
Mm-hmm.
The reason it works in Svelte is that with Svelte, you write this code and then you compile your application. Because when you're building with Svelte, you're not writing JavaScript, you're writing a custom language called Svelte. And it compiles into JavaScript where it adds a bunch of stuff that probably looks a little bit like this, which isn't to say that the two are exactly the same. They have totally different mechanisms. But the point is that this is actually impossible. Like, you can't do this in JavaScript. And so what that means is that it's going to have to build something more complex. So you're not avoiding the complexity with Svelte.
You're hiding the complexity, and this is part of the role of software engineer. The history of software engineer is one above rising level of abstractions.
Kind of, you're putting a curtain in front of it. You're veiling the complexity, which can be good, but it can be bad as well. Okay, but you might be thinking, okay, well, I need to tell React to re-render. So let's say that we have like a magic wand, and we can just add whatever APIs we want to React. Why don't we add a react.re-render method? And the idea is the developer would call this method whenever they want React to re-render. So we create a variable count, we increment it by 1, and then we tell React, hey, it's time to re-render. Well, this also doesn't work. And it's a little bit complicated. We're going to have to kind of dig a little bit deeper into how React and really how JavaScript works. And to help me with this, let's actually forget all about React for a second. Let's push that down out of the way. Let's say I have a function, hello world. And inside this function, I have let count equals 0, count equals count plus 1, and I call this function. When I run this code, it creates a variable, it increments it by 1, and then nothing else happens, right? It will eventually signal to the engine that, hey, we're not using this thing anymore, and the garbage collector can come along and wipe it out, right? By not doing anything with this variable, we are scheduling it for deletion. And if I call this function again, we reinitialize a new variable and we increment it by 1. Mm-hmm. So in every time I call this function, the count variable will always be equal to 1. It's not like the that incrementing feature, right? This incrementation doesn't persist across function calls.
And here is, you want to now persist is this value here. Then what you do is that you define a function that wraps the outer scope to effectively create now a closure. So a closure is a way for a function to remember functions from the outer scope in the inner scope, even after that function is executed later. This is when you deeply need to understand now JavaScript, man.
JavaScript doesn't really give us a way to like thread.
And this is why now this particular concept of closure, which is something that we see, what I see in previous videos, this concept of closure here is the way how now allow us to wrap algorithm with collections of values in one single bundle, in one single model as a closure, and then unlock other mechanisms that we can go with.
a value through function calls like this. Other than moving the variable outside the function, right? This would work, but that's not really what we're talking about here, right? So let me get rid of all this. Let's go back to React. When we write an app component, right? Components in React are functions in JavaScript. And if we think through what this function does, well, at some point in our application, let me give myself a little more space, we're going to have react-dom.render app. And if we transpile away the JSX, this becomes react-dom.render react.create element app. And if we were to imagine calling this function, right, running this part of the code, well, we would get an object. This is a React element, which is a JavaScript object. It would have type app, and it would have a bunch of other stuff, right? It would have the props.
You have the
The
props.
point is, when we pass
keys.
this object to react-dom.render, React is going to invoke the app function. And it's going to invoke this function every time we trigger a re-render. So what it means is that inside React, we have app being called, and then it's going to be called again, and called again, and called again, right? We can imagine a timeline where we have the very first render at first, and then a re-render, and then a re-render, and then a re-render. And the problem with this scenario is every time I render the component, I'm resetting the value to 0, right? Because it's defined inside the function, it's always going to be reset to 0 every time we do one of our renders. You might be thinking, well, what if we move it outside the function? And now we get into even murkier territory. For one thing, how would we signify that this is a state variable, because it doesn't exist within the component? How would we have multiple instances of this component, right? Like if we had a button component, we might want to have 3 or 4 of them on the same page at the same time. So it needs to be defined within the component so that every instance can have its own dynamic state. I realize we're getting like way into the weeds here, and I worry a little bit that I'm not really making any sense. But suffice it to say, React exists within the context of JavaScript rules. And if we define a variable inside a function, that variable is going to be reinitialized every time we call the function. So if we go back to how things were initially, right, the proper React way of doing things, we can start to see why these pieces exist and why they're necessary. We need to have some way to access the current value of count without redefining it in every function, where I actually
React
set
behind
count
the scene is
equal to
not
a hard
creating
value
like a
this.
closure.
What I need to do is set count
this
equal to
state
something
and
from inside
providing you
React,
now
like
a
react.get
function for it.
value for state or something. And that's kind of exactly what this is, right? The react.useState method is reaching into React and plucking out the state variable, so that on the very first render, we're giving React the value and then plucking it out into this count variable. But on the second render, we're reaching in and grabbing the new value. And on every subsequent render, that's how this works, right? We're plucking the value from inside React, which exists outside the scope of this function. In terms of why we also have a setCount function and we can't simply increment this value, well, JavaScript doesn't give us a way to observe value. So we need to tell React that it's time to render. And actually, the setCount function is kind of clever because it's doing 2 things at once. The primary thing that it's doing, the thing we think of, is we're changing the value, right? We're scheduling the new value so that when it re-renders the next time, this count value plucked from within React is going to have the new value that we're setting over here. But we're also signaling to React that it's time to re-render. That's the secondary thing that it's doing. I think a helpful way to think about React is essentially as a series of snapshots over time. So when you first call react-dom.render, you get kind of your initial snapshot, and then whenever you call a set function like setCount, you get another snapshot, and then another snapshot, and another snapshot. And for each of these snapshots, the state variables are being populated from within React. And if you wanted to, you could kind of zoom in and say, okay, at this moment in time, count was equal to 4, let's say, and this was the UI that was generated as a result. It would say you've clicked 4 times because that's the current value of this state variable. It's easy when we look at the Svelte meme to kind of be a little bit wistful and kind of wish that we had a much simpler way of doing things in React. But the thing is, it's not as simple as it looks, right? It can't be, because JavaScript just doesn't make this sort of thing possible. So you're not avoiding the complexity, you're kind of just brushing it under the carpet. And this can be good if the abstraction is airtight and if you never have to worry about it. But in my experience, that's almost never possible. Like, I used to use a tool called Ruby on Rails. And Ruby on Rails is a web framework that is known for its magic. So you write this little bit of code that's super nice and easy to understand, and all this stuff kind of happens for you automatically. And the problem with this is that eventually you run into a misalignment between how you think it works and how it actually works, or maybe you do something in a slightly unconventional way, or there's just some weird niche bug in the tool. Something can happen that throws you off this nice treaded path, and now all of a sudden you're lost in the woods. Like, it can be really hard to figure out what's going on when you're using a really magical tool. React is also plenty magical, right? Most React developers don't have a super perfect understanding of what React is doing under the hood, but it gives me a little bit of comfort to know that it is always operating within the confines of JavaScript, right? It's not doing some sort of special magic that's only possible because it's compiling from another language. There's a limit to how much magic we can have.
Because you don't actually understand what's going on, and it's literally impossible to fix the problem because you don't understand them. I have spent so many days in the trench with Ruby on Rails, trying to find my way back to the happy path. The React way was the React way has a steeper learning curve, and it can feel a lot of more high friction. But now what I understand it, I never feel like I get lost in the woods, and that's the part of what makes React so nice to use. Forest of Illusion. Okay. Okay. That's interesting. So let's read about the Mhm. Let's take a look now at this one, at the forms here. So forms are one of the most disliked aspect of front-end development. We hate building them. You hate building them. I don't. It's, so this hate, this likes and dislike is, they're not effective. It is irrelevant. It is irrelevant. Basically, it is irrelevant. You hate it or like it is because you don't understand it. That's what happened. And yet forms are super important. They are everywhere. The world's most popular website, google.com, is literally just a form. The React ecosystem is huge, And there are a lot of packages out there claiming to solve forms. In my opinion, however, they aren't necessary. Most of the time, forms aren't actually that bad to work with in React. So in the lesson that follow, we'll learn how to set up data binding with form inputs. Learn about one of the most critical concepts in React development and see how we can build longer forms with fewer headaches. Okay. We'll learn how to set up data binding with form inputs, and learn about one of the most critical concepts in React development, and see how can we build longer forms with fewer headaches. So data binding on the onClick parable and other form control, as well as the exercise. Okay. Let's make a quick recap here. So the React exactly. So in the lesson that follow, you will learn how to set up data binding with form inputs. How to set up data binding with form inputs, whether it's input, radio buttons, checkbox, select, text area is another form inputs. Interesting. I would like to know is what are the form inputs here. I would like to know what are the possible inputs here. Exactly. Which is the button, the checkbox, the color, date, datetime locale. Interesting. This is now by the default, exactly. So the browser provides this functionality. Okay. So the browser provides now this functionality here. Interesting. Okay. So the browser now provides this functionality. Okay, perfect. Okay. Okay. Date, datetime, locale, email, file, hidden, image input. The image input type image. What the French does? Oh, you can use that. Fuck that shit. My god. Holy fuck. As an image, bro. You say, hey, whatever. Holy hell, bro. Okay. Input image. Okay. So you say, hey, this is gonna look like this. As an image. Input image, month. If you only want to pick up the month, number, password, radio, range. I am not quite familiar with range and how to even work with that. Type range, and you have now this, all right, which is min and max, similar for the other one, which is min and max. And what are the steps? Step by 10. If you don't specify none, it's going to go 1 after another. So for example, if you remove this step here, now it's more smooth. But if you don't, you can see it go to one particularly that. The other is a reset. Inside of the form, you have also is the type reset and the type submit, mother. Holy fuck. Okay. The other is the search. A single line text field for entering search string. Line breaks are automatically removed from the input value. Line break are automatically removed from the input values. The search the site, search my value here, or search value. Pattern, read only, size, spell check, non-attribute results. So you got the search, you got the submit, an input type submit, and value send request, or input type submit. Okay, most of the time we use is the button instead of an input, the input tail. All right, and you can now specify is the particular pattern you want to go with. But it seems doesn't take that pattern, despite the fact this browsers that don't support type tail fall back to being a standard text input. But it's interesting because they are not supported by it, and they can also is provide this as it is. Pattern validation and examples here. Area code, first bar, and the second bar. Okay, but some browsers they don't support that. Implementation, no. Some browser implementation they don't support that. They say, hey, you know what? No, deal with that. I'm not gonna deal with you. Text, time. Okay, URL. And the pattern is this. Weak. Limited availability. Interesting, very, very interesting. You can now choose the week. Holy moly. Okay. The week and some obsolete values datetime. Holy French toast, bro. This is all the type of this is all the type elements that we can have. Most of the time I'm quite familiar with bottoms, checkboxes, color, date. This is only taking that particular date, datetime, locale, email, file, hidden, all right, image, month, number. I am not quite familiar with image, but also you can define it as the radio buttons, range, reset, similar for the reset and the submit. Okay, line breaks are automatically removed from the input value. May include a delete icon in supporting browser that can be used to clear the field. Display a search icon instead of entering the key on some device with dynamic keypads. But the reset here, and reset and the submit. You should avoid including reset button in your phone. They are rarely useful and are instead more likely to frustrate users who click them by mistake, often while trying to click the submit button. They exist, forget about it. That's interesting. That's interesting. They exist, forget about it. Time URL. Okay. That is quite interesting, my friend. That is very, very, very interesting. Holy French toast. That'll be all for this video. Take care. Bye bye.